All right, so in this video, we're going to actually do a couple more examples from section 11.5. I said we were going to start 11 point, or we were finished with 11.5, but I forgot I skipped two examples that I wanted to do. So we're going to quickly do a couple more examples from page 741. Oops. We are going to do number 8. Number 8 says find parametric equations for the line that contains the point 3, -1, 2, 3, -1, 2, and is parallel to the line with equations. So it contains that point, and parallel to the line with equations x minus 1 over 4 equals y plus 3 over 2 equals z. All right, so now remember that what you want to constantly keep in mind is if I need to find the equation of a line, all I need is a point on the line and a vector that's parallel to the line. So we have right now, they gave us a point that's on our line, then they just gave us another line. They didn't give us a vector, they gave us another line entirely. But these two lines are parallel to one another. So if the two lines are parallel to one another, that's one line. That's the other line. Then any vector that's parallel to one of them, this vector, is parallel to the other one. So say they gave us the red line, we're supposed to find the green line. All we need is, we don't need the red line. What we're going to do is take from the red line its vector that's parallel to it, and we were given a point on the green line. So now we have everything we need to find the equation of a line. We have a point on the green line, and we have a vector that's parallel to the green line. Whereas the vector that's parallel to the green line, we have to squeeze it out of these equations right here. All right. So we're going to take the red line's vector and use it for the green line. So from this, what is the vector L? Remember that L is not from the numerator, but things that you see in the denominator here. So here we have L is 4, 2, 1. Now, remember I said that sometimes people may use a different vector. Any vector that's parallel to this will work. Now, the natural thing is to use 4, 2, 1. But if somebody decided, you know what, I want to multiply this vector by pi. As long as you multiply the entire thing by some non-zero constant, doesn't matter what you multiply by, that is still a legitimate vector. So somebody could say, okay, well, I'm going to use 4 pi, 2 pi, pi. And then you look at their answer to the problem, and theirs looks different from yours, but it's exactly the same as yours. So it doesn't matter. Any vector that's parallel to this will work. All right, so now we have a point on the line and a vector parallel to the line, and we can easily find our parametric equations, which is what they asked for from this information. So don't mistakenly use x naught, y naught, and z naught from here, though. We need to use this x naught, y naught, and z naught. So x equals x naught, which is 3, plus at, so plus 4t. Y equals y naught, which is -1, plus bt, and z equals z naught, which is 2, plus ct. And we have our parametric equations for that line that passes through this point and is parallel to that line right there. All right, next we're going to look at number 10, which says find parametric equations for the line containing the points -1, 1, 0 and -1, 5, 7. So parametric equations for the line containing -1, 1, 0 and -1, 5, 7. So you immediately ask yourself, when you see equations for a line, you ask yourself, okay, can I find a point on the line and a vector that's parallel to the line? So we have 2 points on the line. So when you pick whichever one you want to, and either one will work fine for finding the equation. Now what we need is a vector that is parallel to the line. So one thing you keep in mind is the information that you've known from previous courses, that if we wanted to find an equation, any 2 points determine a line, and we can use that information to give us the vector that is parallel to the line. So these 2 points right here will determine a line. So that means those 2 points alone will give us a vector as well. So we can look at it as taking a portion of that line as the vector that you need. So we'll say our L that we need, we're going to use these points to get it. And it doesn't matter which way you go, as long as you maintain the same thing. So you can go from this point to that point or vice versa. So this is -1 minus -1, and then 1 minus 5, and then 0 minus 7. So now I have my L, so -1 minus the -1 gives us 0, 1 minus 5 gives us the -4, and then 0 minus 7 gives us -7. So now we have a vector that is parallel to our line, and now we just use whichever one of these points that we want to. I'm going to use the first point. So now we have our parametric equations. Is what they asked for, correct? Yes. So our parametric equations are x equals x naught, which is -1, plus 0t. Then y equals y naught, which is 1, minus 4t. And then z equals z naught, which is 0, and then minus 7t. And those are the parametric equations for our line. All right, so that actually does conclude what we'll do in 11.5, and we'll move on to 11.6 in our next video.